Alright, first we'll get to learn more about APIs. I mentioned in the introduction of the module already, it is rare that you'll build an application with hard-coded data. Our Blazor application will need access to real, up-to-date data. So how do we access that data from our Blazor app? To work with real data in a Blazor app, we actually have a couple of options. In most cases, an application will need access to server-side data, so up-to-date data that it needs to retrieve elsewhere. A client-side WebAssembly Blazor application won't be connecting using, for example, Entity Framework Core to a server-side database. In this case, our Blazor application would need database credentials to log into that remote database. Definitely not a good idea. Working with EF Core from Blazor is possible in the Blazor server app though. But that's not what we are using here. So what we'll need is a better way, and that is using a REST API. In this case, we'll use HTTP communication to fetch data from a database that sits behind a service. A second option to work with data is using local storage, so purely client-side. In this case, we can use the local storage feature of the browser to store data, for example in JSON format, and use that in our Blazor app. Of course, this is just local data. It's not going to give us the option to get up-to-date data from our backend in itself. But it's interesting to know that Blazor can actually do this. This also can be a very useful feature should you decide to create a Blazor app that needs offline capabilities. You can indeed use local storage to store data, and when the connection would be available again, send any offline changes back to the server. When we talk about an API, we're looking at a way to interact with the server to get access to just the data. Using ASP.NET Core MVC, for example, we're getting back HTML, a full web page that's going to be rendered by the browser. In our Blazor app, we're only interested in the data instead of the HTML. That's where an API or a service comes in. We will, just like with a method, return data to the caller. The caller here will be the client, so in our case that's the Blazor application, which doesn't want the full HTML, but it just wants the data. On the API, we will define an endpoint that returns indeed just the data. With just the data, I mean typically the data in JSON or XML format. Both are ways of representing the data. JSON, which stands for JavaScript Object Notation, is a very compact way to represent data in a key value format, and that is what we'll use most often. Both JSON and XML are standards, and they are used in many technologies. We are going to work with an API that is built using ASP.NET Core, and that API can be consumed from many other types of clients. For example, a MAUI or Xamarin Forms application, another API, a desktop application, or even a native iOS application. And of course, also from a Blazor WebAssembly application. The type of API we will create in this case is a RESTful API. REST is again an abbreviation which stands for Representational State Transfer. A RESTful API uses the HTTP standards and follows a few rules. When we create a RESTful API, what we are going to do is accepting an incoming HTTP request. Clients can send to the API a GET, a POST, a PUT, and so on. That is indeed pretty common stuff. Clients will send this request to a resource through a regular URL. A resource is pretty much everything we can address through a URL. Say, for example, that we're going to create an API that will return us a list of all employees. Well, that endpoint is a resource and it's going to be addressable through a unique regular URL. When the request is received, the API will respond using JSON. The data, in our case the list of employees, will be wrapped in JSON typically, and that will be returned to the client, along with a status code. If all goes well, the API will return a status code 200. That is the HTTP status code for OK, all went well, and here is the data you wanted. Other status codes can also be returned. Say that we have an endpoint that can return the details of an employee and we are passing the ID of a non-existing employee. In that case, the API should return 404, the well-known HTTP status code for not found. In short, a RESTful API is based on these core concepts, and that is what we will use here too. Here you can see this in action. The Blazor application, running inside the user's browser, will send a request to a resource. The request is a regular HTTP request, for example, a GET request to a certain resource represented by the URL. On the API, built with ASP.NET Core in our case, this request is received and will trigger the execution of code. If all goes well, a response is sent back to the client. That response will typically have a status code indicating how the server could handle the request. This hopefully will be status 200 if all goes well, and probably JSON data will be included. Based on this response, the client can act accordingly. Based on the HTTP verb, a REST API will perform a certain action. Indeed, the HTTP verb that comes in will determine what the API should do. Here are the most common HTTP verbs. GET means give me a result. POST is used to create a new instance or record typically. Say that you are creating an API that allows to create new employees. The POST request will typically contain all the data to create an employee on the server and insert it in the database. A PUT is for update requests. So if you want to update the employee from the client, we'll send in an updated employee combined with the HTTP PUT verb. If we want to perform a delete, well, then we can indeed use the HTTP delete verb. I have mentioned JSON a few times already. It's, as mentioned, the most commonly used way to send data to and receive data from an API. It is compact and thus very little overhead is incurred. It's a standard and it can be easily consumed in many technologies. Here you can see a snippet of JSON to represent a set of employees. Each employee is represented as a JSON object, so between curly braces. And each data property will be represented using a key-value pair. The key is the name of the property, whereas the value is the actual data, the value of the property. The entire set of employees is here in fact represented as a JSON array, which we can see by the square brackets that surround the different JSON objects. Now we won't be writing any JSON ourselves. We'll have our API create the JSON based on the objects that we hand to it.